Hello everyone and a very warm welcome to everyone for our presentation for KPIT Sparkle 2019. The name of our topic is Manual to Self-Driving Car Conversion Kits, and these are our group members that are going to participate. So this is how the roads are going to look like in the coming future with the help of technologies emerging related to self-driving cars. Now this is what a self-driving car basically includes. It includes LiDAR and other sensors, computer and software, along with other orientation sensors. At present, there are more than 250 companies working on self-driving car related technologies. So this clearly implies that self-driving cars have their own set of problems which these companies are working to solve. Following are the problems in the context of self-driving cars we intend to solve. These are some of the companies that are working on this technology. The list is tremendously huge. Now let's look at what the real problem is. In order to reap the benefits of self-driving car technology, one has to buy the latest cars offered at high prices at around 70 to 90 lakhs or sometimes even more. In this process, the existing cars running on the road become less attractive and might be on the verge of eventually become obsolete while these new age cars keep coming. In India itself, the sales of cars crossed 3 million mark in 2017. This would lead to an increase in the number of cars on the road, thereby leading to problems like fuel scarcity, traffic, air pollution, etc. While companies like Google, Tesla, Uber, etc. have claimed to develop fully autonomous systems and cars, the recent accidents of self-driving cars of these companies have made it clear that a fully autonomous car system is still a distant dream, and hence partial autonomous systems should be the way right now. Here is a list of autonomous car fatalities occurring while autonomous systems acknowledged to have been engaged. Now these are the SAE levels of autonomy. Level 0 is no automation, that is the cars that you see running on the roads right now. And it goes all the way up to fully autonomous systems, that is level 5 systems. As discussed earlier, level 5 autonomy is still a long way to go. So what we have decided for our project is to develop a partial automation or autonomous system, that is of level 2, in which a vehicle has combined automated functions like acceleration and steering, but the driver must remain engaged with the driving task and monitor the environments at all times. So if the vehicle is not able to make any decision, the driver has to take over and control the vehicle by itself manually. Now let us have a look at what are the technologies that are involved in a self-driving car. Self-driving car basically consists of computer vision, sensor fusion, localization, path planning, and control. In computer vision, a lot of data is fed to the computer in order for it to recognize other objects around itself, such as other cars, the mapping of lanes, reading of road symbols, and detecting humans and other objects. Sensor fusion involves the combination or the sensing of the environment around it. On the left, you can see a LiDAR mapping the world around itself, and on the right is the car on which the LiDAR is mounted. Localization is the process in which the car gets to know where it is in the world in order for it to move from one position to the other. This can be achieved by sophisticated algorithms like the one shown here. Then we have path planning, in which the car gets to learn how to change lanes and how to detect objects and make decisions. This is Carla, an open source simulator by Udacity. After this, we have to control the three main actuations, three controls of a car, that is acceleration, brake, and steering. This is Udacity's open source lake simulator, in which the green line is the ideal path and the yellow line is the path that the car has to follow. Here is a block diagram in which the car or the simulator would be controlled by three different parameters of accelerator, brake, and steering. The kit will receive inputs from the environment using camera, LiDAR, ultrasonic sensors, etc., and radar, and determine the objects and its relative locations and velocity so that it can plan paths dynamically using the trained model. Now let us have a look at some of its pros and cons. The advantages are as follows: accident prevention, reduce human errors, cost reduction, road condition dataset diversity, sensor corresponding data accuracy. The limitations of this technology are as follows. The limitations of this technology are as follows and should not be overlooked. The limitations of self-driving car should not be overlooked. Currently, there are two main weaknesses in this technology. Number one is the lack of emergency situation scenarios, and number two is the potential consequences of differences between real and simulated data. Now, here is a workflow of our project, which includes research and information collection in the first month, skill development in the second month, simulator coding and prototype designing in the third month, prototype designing in the fourth month, data collection and training in the fifth month, and implementation and testing in the final month, that is the sixth month. I would like to conclude our topic by saying that the main agenda of making manual to self-driving car kits is to convert the already existing cars into self-driven, that is level 2 autonomy. Safety is our number one priority. We plan to implement this project in real-time environments and commercialize our product as it has very wide customer domain. Thanks a lot for listening to us. Thank you.